Hi, it's James here, and today we're here to talk about first and second partial derivatives. So let's get into it. The question is, find all first and second partial derivatives of the function f of xy equals 9y cubed plus 2x to the 10th y to the 5th. So this first question is asking for the first derivative of the x. So what's going to happen here is, here's a little note right here, is 9y to the third is going to equal 0 because it is a constant, because it has no x variable at all. So that's going to be 0. And then you're just going to use the normal rules, and it's going to be 10 times 2, which gets you 20, subtract the 1, 9. And y to the 5th's there because it is with it. It's all 1. So you have to keep that together. The next one's asking for the first partial derivative of fy. So here, we're going to keep the 9y cubed. And it's going to be the same rule. It's going to be 3 times 9, 27. Y is subtract 1 to the second. And then it's going to be plus 10y to the 4th, because this 5 above the y is going to go to the 2. So it's going to be 10. And you're going to subtract 1 from the 4th, and the x to the 10th will stay the same. Here we are finding the second partial derivative of f and both the x's. So you're finding the second partial derivative of this first one. And that's where we're just going to use the same rule. It's going to be 9 times 20. So it's going to be 180x, subtract 9, 1 from 9, get 8, and y to the 5th will stay the same. Next, it's going to be the same, still asking for the x, but we're looking for the y in this one. So it's going to be the y to the 5th, you're going to take the 5th and multiply by the 20 in front of all of it, and subtract the 1, so it's going to be 100y to the 4th, x to the 9th. The x to the 9th stays the same. And then the next one's going to be the same one, so that's going to be another big point. These two you want to check to see if they are equal. That's going to be very big. And this last one here, you're just going to use the same. You're going to use the first derivative for y, partial derivative for y. You're just going to use the same rule. Add multiply the 2 to the 27, subtract 1, so it's nothing. And then the same with the y up here. You're going to take the 4 and multiply by the 10. X to the 10 stays the same. So the final answer is going to be 54y plus 40y to the third, x to the 10th. Let's go to the second part here. The function L(w) of t gives the length in centimeters of a river trout that weighs w grams and is t years old. This first question is asking us to write a sentence of interpretation for L 750 and 4 equals 40.7. Include the units. So here it's going to be a river trout that weighs 750 grams. That's what the 750 is. It's the grams and weight because of w. And is 4 years old. That's the 4 years old t. Will have a length of 40.7 centimeters. So you get the centimeters because that's the output of all this right here. This next one. Write a sentence of interpretation for L with respect to t, 754 equals 0.34. Include the units. So this one's a little more difficult. When the river trout weighs 750 grams and is 4 years old, that's the same. The length with respect to age, with respect to t, increases by 0.34 centimeters per t years old. That's gonna be important because it's gonna be the output over whatever these units are. All right, that is all.